Good morning. Welcome to another session of EE403 Distributed Generation and Smart Grid. In the last session, we had seen home and building automation, and today we will see intelligent electronic devices which are commonly used these days in substations and substation automation. Before we proceed further, let us see a quote by Rajagiri Naidu. We want deeper sincerity of motive, a greater courage in speech, and earnestness in action. So we are into the fourth part of module 3. So we will see IED and their applications for monitoring and protection. Before we move into IEDs, let us refresh what you already studied in protection in S5. So let us see what are the data acquired from relays and circuit breakers. You can see this picture. The output of the relay goes to the circuit breaker and operates the circuit breaker, and we get real-time values of single phase currents or the phases IA, IEB and IC, then bus voltage VA, VB and VC, three-phase watts, we can say kW, three-phase VARs kVAR, then trip close status and control, and reclosure status and control. So these are the data acquired by relays in any protection system. Now let us see remote terminal units, or abbreviated RTU. These are wired to the circuit breaker contacts in the substation switchyard. This is I'm talking about a traditional power system monitoring and control. So data is collected by RTUs which are located in the substations. They also collect analog data obtained through transducers and instrument transformers. This data is fed to the SCADA systems. SCADA stands for Supervisory Control and Data Acquisition. Now the drawback of this system is the design of SCADA is not robust. There may be some errors because of some malfunction occurring in the CB contacts, transducers, communication equipments or RTUs. Secondly, SCADA has relatively slow scanning rate for measurements, 1 to 10 seconds. So it can't track dynamic changes occurring in intervals shorter than the SCADA scan time. So these drawbacks of SCADA can be overcome by data captured by using IEDs, or intelligent electronic devices. So what is an IED? IEDs are microprocessor based controllers of power system equipment such as circuit breakers, transformers and capacitor banks. IEDs are required in smart grids to manage the balance between the need of the users and the integration of DG equipment with the electrical system. So without IEDs, smart grid cannot work. These IEDs are installed in substations for automation in data collection and analysis, improving data integration, monitoring, control and protection. Data sampling synchronization is the major advantages of IED. We will see this after some time in detail. Local sampling synchronization and system-wide synchronization, both are possible. IEDs can be interfaced to GPS receivers to provide synchronization with accurate system-wide clock Sample data can be correlated between different substations or internally in a substation between different recording instruments. So all this makes IEDs more attractive. So this shows an IED where it can be used for monitoring, metering, protection and control. Satellite time synchronization is available. A human machine interface or HMI. Using this we can change the settings, configuration, programming, then we can get all the analysis, and events can be recorded also. And there is a substation server to which IEDs are connected, and also it is connected to a modem for office and home automation or transmit to a remote cloud. Here you can see a 132/11 kV substation model with a double bus arrangement, and you can see various IEDs connected. You can see IED 1, 2, 3, 4 connected to feeders, 5, 6, 7, 8, 9 and 10, 11 and 12. So almost 12 IEDs connected in this double bus circuit, which can give all the necessary information required for activating the protection and also recording. 3 different types of IEDs we will consider here. The first one is Digital Protective Relay or DPR. This is designed to monitor operating conditions on a transmission line and trip circuit breakers when a fault is detected. So operating conditions here we mean abrupt change in impedance, current, voltage, power flow or frequency. So these things will be monitored, and accordingly a trip signal will be sent to the circuit breakers. Secondly, Digital Fault Recorder or DFR. This is designed to capture short duration transient events, long-term disturbance and trends of input quantities such as RMS frequency, harmonics, power and power factor. So this DFR records large number of data after being triggered by a preset trigger value. And lastly, the circuit breaker monitor CBM. It is designed to monitor CB condition online. CB condition means signals in the control circuit during the opening or closing of circuit breakers. This picture shows the data integration done in a substation. So signals are coming from DFRs, DPRs and CBMs, and also SCRs. SCRs stand for substations, event recording, PLCs, programmable logic controllers, PQ meters, remote terminal units and phasor measurement units. So a large number of data is coming from all these devices, electronic devices, and it is integrated, and finally it is used for either storing, monitoring or protection of devices. This is another picture of data integration. Various signals coming from DFRs, DPRs, CPM, RTUs and SCRs are configured and then converted into COMTRADE format, and then it is used for DFRA, DPRA and CBMA. These things we will see in the following slides. These are basically creating different types of reports. Applications are developed for processing data obtained from CBM, DPR and DFR. So we get CBMA or circuit breaker monitor analysis. digital protective relay analysis, digital fault recorder analysis, DFRA. Now what CBMA do is it performs analysis of data in COMTRADE format taken from the circuit breaker control circuit using a CBM, and generates report in ASCII format that describes the CB operating conditions and suggests repair action. And COMTRADE stands for Common Format for Transient Data Exchange for Power Systems. It is a file format for storing oscillography and status data related to transient power system disturbances. And ASCII, all of you know ASCII, American Standard Code for Information Interchange. So basically it gets information from CBM and performs various analysis of the data and generates report, and this report can be used for circuit breaker operation or for analysis purpose. It is again shown here. See, this is the software architecture of CBMA. You can see there are you can see the event reports generated by the CBMA, and these files are in the COMTRADE file or COMTRADE format, and various signal processing and expert processing of the data obtained from CBM is done here. So this is again the CBM software architecture. Another picture that's in the DFR recording comes from outside, gets signal processed, and the extract parameters are fed to an expert system, and any expert system will have some expert system settings and a set of rules, and depending on these rules and settings, the expert system will produce an event report. Next is the digital protective relay analysis or DPRA architecture. This is another expert system which automates validation and diagnosis of relay operation. So here also the function is to get signals from DPR and produce and do necessary analysis and produce a report. And finally, the digital fault recorder analysis or DFRA. So this also provides provides reports after the automatic analysis, and it gets signals from DFR event records. It performs signal processing to identify pre and post fault analog values, status of digital channels, fault type, faulted phases, etc., and generates various reports. Now where we can use the IED data. So this IED data can be used for information for system operators, information for production engineers, and for maintenance staff. These are the various abbreviations used in this PPT, and these are the major references you should go through. And with that, I am Dr. Unnikrishnan PC signing off. Thank you very much.